The recent clear ground exposure of the J-50 fighter jet, does it signal that China's sixth-generation carrier-based fighter era is accelerating toward us? As two photos hailed by global military enthusiasts as the best viewing angle circulated online, this sci-fi-inspired Northern sixth-generation fighter undoubtedly sparked profound contemplation about the future landscape of maritime and aerial warfare. Compared to Chengdu's J-36, Southern sixth-generation, Shenyang's J-50 showcases a radically different technical path with its unique lambda wing and tailless design. This represents not only the strength of China's aviation industry, but also a revolutionary departure from traditional fighter design concepts. The J-50 adopts a compact tailless single-seat configuration, eliminating conventional vertical and horizontal stabilizers. Flight stability and control are achieved entirely through its high-sweep delta wings and full-range movable winglets. This design enhances aesthetic appeal while underscoring its pursuit of exceptional maneuverability. The lambda wing ingeniously reduces radar cross-section while significantly improving takeoff, landing performance and supersonic cruise capabilities. Maintaining a high aspect ratio, it ensures consistent sweep angles at both trailing and leading edges, enhancing stealth by minimizing peak scattering waves generated at the wing's trailing edge, achieving near-perfect stealth. Fully movable winglets maintain superior yaw control during high angle of attack flight while suppressing dangerous conditions like tailspins. This represents a significant advantage for sixth-generation fighters seeking a balance between high maneuverability and stability. From an aerodynamic perspective, the J-50 achieves near-perfect equilibrium between stealth and agility, featuring drastically reduced radar reflectivity and omnidirectional stealth capabilities that demonstrate exceptional survivability across diverse battlefield environments. The J-50's nose features an extremely steeply angled, flattened diamond configuration that substantially enhances stealth performance. Its long, large-diameter radome houses a phased array radar larger than that of the J-20, boosting long-range target detection capabilities. The OTS window beneath the fuselage and distributed sensor system enhance infrared surveillance and target identification, virtually eliminating visual blind spots. The absence of external hardpoints indicates a fully internal weapons bay configuration. Two concealed internal weapon bays are positioned beneath the fuselage, while side bays may accommodate electronic equipment pods. Latest imagery reveals the J-50 equipped with twin engines, a bypassless supersonic inlet, and 2D thrust vectoring nozzles, further enhancing maneuverability and stealth characteristics. Thrust vectoring technology provides additional control torque by adjusting engine jet direction, significantly boosting the fighter's agility, a critical feature for the J-50's design lacking vertical stabilizers. Renowned aviation analyst Andreas Ruprecht believes these photos are highly credible, likely taken by someone at the perimeter fence of Shenyang Aircraft Corporation's facility. The absence of air data probes on the nose landing gear suggests the aircraft has entered a new testing phase. Notably, the J-50's nose landing gear features a dual-wheel design, a hallmark of carrier-based fighters. This dual-wheel configuration better accommodates the impact forces during carrier takeoffs and landings. More strikingly, the clearly visible stop bar on the nose landing gear strongly confirms its carrier-based identity. Stop bars are specialized designs for carrier aircraft, securing the plane to the catapult to ensure a smooth launch. This detail unequivocally demonstrates that the J-50 is indeed engineered for carrier-based operations. As a potential sixth-generation carrier-based fighter, the J-50 faces the highly challenging task of achieving precise carrier landings. While eliminating the vertical tail enhances stealth capabilities, it increases horizontal maneuvering difficulty. Carrier landings involve complex airflow conditions, demanding exceptional precision in approach maneuvers. The J-50 may address this challenge through three technical approaches: full-range movable winglets, dual-engine thrust vectoring, and vectoring nozzle control. Regardless of the method chosen, an exceptionally precise flight control system is required to analyze airflow data in real time and coordinate all control surfaces. This places demands on flight control system coding that far exceed those of previous carrier-based aircraft. From an operational perspective, the J-50 and J-36 exhibit distinct differences. The J-36 is a twin-seat heavy fighter emphasizing long-range, all-around strike capabilities, akin to an airborne cruiser. In contrast, the J-50 is a single-seat medium fighter prioritizing high-speed flight, exceptional maneuverability, and information warfare advantages, focusing more on air superiority capture, like a nimble airborne destroyer. This differentiated development reflects the strategic layout of China's aviation industry and sixth-generation fighter development, balancing multiple requirements for land-based and carrier-based operations. air superiority, and strike capabilities. The recent surge in leaked images related to sixth-generation fighters may signal broader strategic shifts within the PLA. This limited information disclosure strategy aligns with the approach taken during the 9/3 military parade to showcase advanced equipment, reflecting strategic confidence in playing with an open hand. By conducting tests in densely populated areas, China's aviation industry demonstrates technological prowess while leveraging the internet for effective public opinion dissemination. Currently, China holds a clear lead in the global sixth-generation fighter development race. The U.S. GAD program faces cost and technical challenges, while Europe's Tempest and Future Combat Air System projects both planned deployments between 2035 and 2040. In contrast, China has simultaneously unveiled two engineering prototypes that have completed maiden flights, demonstrating a comprehensive industrial system and rapid iteration capabilities. Sixth-generation fighters are dubbed flying supercomputers, capable of processing massive data volumes and sharing real-time intelligence with all combat units via data links. Their defining characteristics can be summarized as 6 super capabilities: ultra-low profile aerodynamics, supersonic cruise, unconventional maneuverability, ultra-long range strike, multidimensional connectivity, and trans-domain control. Artificial intelligence technology is the hallmark of sixth-generation fighters, deeply integrated into avionics, flight control, and other systems. As a sixth-generation fighter, the J-50 will inevitably possess these characteristics, particularly AI and unmanned system collaborative combat capabilities. The latest photos reveal a subtle, ventral groove designed beneath the J-50's fuselage. This feature primarily enhances directional stability during high-speed flight. Some analysts suggest it may employ a flexible structure that expands or contracts based on flight conditions to minimize impact on stealth performance. The ventral groove between the main landing gear splits the primary weapons bay into left and right sections. Judging by the distinct contours, each compartment can carry at least 2 PL-15 long-range air-to-air missiles, or PL-17 ultra-long-range air-to-air missiles. The J-50 and J-36 both made their maiden flights on December 26, 2024. This simultaneous debut fully demonstrates the technological confidence and strategic coordination capabilities of China's aviation industry. The rapid advancement of the J-50 program, from its first flight to multiple test phases, and the emergence of clear photographs, indicates its technological maturity is advancing at a rapid pace. As testing continues, the J-50 is poised to become a vital force for safeguarding national security and maritime, aerial sovereignty within the next decade, playing a pivotal role particularly in carrier strike group development. Through the development of advanced aircraft like the J-50 and J-36, China has demonstrated its leading position in the global race for sixth-generation fighters. The outcome of this high-tech competition will profoundly shape the global strategic landscape for decades to come. The J-50 is not merely a fighter jet. It symbolizes the innovation capabilities of China's aviation industry and the nation's comprehensive strength, marking a historic shift from catching up to keeping pace, and ultimately leading in the field of cutting-edge weaponry.